then it will just be like drinking water. Okay, so I'll just pick one question here, then I'll move on to functions. Okay, so here they're given we're given a lot of questions here on binary. Okay, but if I can just pick one, okay, so I'll pick this B there. Okay, I'll pick this question here, the one I'm circling like that. Okay, so what's the question there? Okay, so the question is determine whether or not each of the definition of this operation star given below gives a binary operation. Okay, or in an event that it does not give a binary operation, justify your answer. Okay, so we said, how do we prove that a certain operation is a binary operation? Okay, we said we are going to use the closure rule. Okay, meaning if we get two numbers from a set of real numbers, okay, and we apply that operation, the answer that you are going to get should also be a real number. Okay, and if that closure property is satisfied, then we say we can conclude that the star there is a binary operation. And if it does not satisfy the conditions, we say the star will not be the binary operation. Okay, so how do you do that? Okay, so I have A star B there is equals to AB squared. Okay, so I have A star B there. Okay, and this is giving me what? A B squared. Okay, so the question there is prove that this star here is a binary operation. Okay, so we're going to use the closure rule. So if this star is a binary operation, okay, on a set of real numbers there, they gave us real numbers represented as R, then it means that, okay, if A, okay, and B are members of this set of real numbers, okay, then for that operation to be a binary operation, even their answer, which is AB squared, okay, should be a member of real numbers, okay? So you get a real number, you apply this operation. If you get your answer, okay, as a real number again, then you conclude to say that that operation there is indeed a binary operation, okay? If that is not satisfied, then that's not a binary operation, okay? So how do we do that? We said we can let A be equals to 2, okay? Then B be equals to, I guess, A -1, okay? So you can get any two numbers as long as they are from a set of real numbers, okay? So we know that real numbers start from negative infinity all the way up to positive infinity like that, okay? So meaning you can get any number in this set, try them there, okay? So if my A is 2 and my B is -1 there, okay? Then it means that I'll apply those B's and A's into this equation and see the answer that I will get, okay? So this is the operation there. So I'll put my 2 there, then I'll say star, B there, which is a -1, is equals to, okay, wherever there's A, I put 2, okay? Wherever there's B, I put what? I put -1. Then I say this squared, okay? So 2 star -1 is just 2 multiplied by -1 squared, okay? So what do you get there? You get 2, okay? What is -1 squared? It's just 1, okay? Meaning the answer that I'm going to get here is just 2, okay? Then now you ask yourself, is this answer that I'm getting, okay? Is this answer that I'm getting a real number, okay? So you can see that 2 is indeed a real number, okay? So I got a real number, applied the operation with a real number, and my answer again is a real number, okay? So if that property is satisfied, then we say that therefore my operation star there is indeed, okay, a binary operation, okay? So that's how you show, okay? That's how you show, okay? So this was how to show. Then I'll quickly go on to this one where they're saying determine whether star is commutative or associative, okay? Determine whether star is commutative or associative, okay? So we said, how do you prove that, okay? We said commutative in simple terms, it means that it doesn't matter the order in which you apply things, the answer will still be the same, okay? And I always give this brilliant example there when I say 2 multiplied by 3 is just 6. Okay, what is 3 multiplied by 2? Again, it's 6. Okay, so the commutative property states that it doesn't matter which one you start with, the answer there is going to be the same. Okay, so if I can solve A there as an example, okay, if I can solve A as an example there, I have on a set of integers, okay, A star B is equals to A minus B. Okay, so I'm going to use that. Okay, so they're saying that A star B, okay, is giving us what? A star B is giving us A minus B. And what set are we using here? The set of integers, okay? So we know that the set of integers is just the a set of all the whole numbers that are negative or positive, okay, including the 0 itself. So all those numbers that are found on the number line, okay? So you have 0, 1, 2, 3, then here you have -1, -2 there, -3, okay? As long as the numbers are whole numbers, okay, and they're negative or positive or they are 0, they are in the set of what? Integers, okay? So how am I going to prove that this is commutative, okay? Commutativity states that A star B here should be should give me the same thing as what? B star A. Okay, doesn't matter the order with which I start with. Okay, then I'm going to say, let me get any two numbers from a set of what? Integers there. Okay, so from a set of integers, I can say my A will be a -2 there. Okay, then I set my B to be maybe 3. Okay, so I have these two numbers there. Then I'm going to test these numbers into this what? Our operation and see if they will give me the same answer. Okay, so it means here we are doing a -2 by, star 3 there, okay, is equals to, then there we're doing a B star 2, meaning we're starting with 3, okay, then we're saying star -2. Okay, so let's find the answer for this and the answer for this and see if they're the same. Okay, so there, what is the rule there? The rule says that you subtract A minus B. Okay, so meaning here I'm just going to subtract my A minus B. Okay, what is my A? It's -2. Okay, minus what is my B? It's just 3. Okay, okay, so is this equal to what is my B in this case? So we are following the same thing here, but in the place of A we now have B, and in the place of this B, okay, we now have A. Okay, so meaning when we operate that, it's going to give us the B there, which is a minus the A there, which is a -2. Okay, so what do you get here? You just simply get -7, and then what do you get here? It's going to be 3. Okay, 3 by 3. Then you multiply minus by minus. It's going to be plus. Okay, then 2. So meaning here you have a -5 is equals to, and what do we have there? You have a +5. Okay, so you can see that this side we have a minus, that side we have a positive. Okay, so the -5 can never be equals to 5. Okay, so since A star B, okay, is not equal to B star A there, okay, it means this operation there is not commutative. Okay, is not commutative. Okay, or commutative. It depends where you come from. Okay, it's not commutative like that. Okay, so I don't know if there are any questions on these binary operations before I move on to functions now. Is there any question? Anyone who has a question, or I can move on? Hello? Guys, can I move on?
Just a bit on the first question.
A bit on the first question?
Yes.
Okay, so what's your
question
on this one?
So it means even these other like A, C, and D, we just have to replace, or we just have to choose any number from the integers, right?
Yes, from the set that you've been given, you choose any number to help you prove.
Oh.
Yes, you can choose any number. You can choose 1,000,000 and 1,000, any number. Okay.